Hey everyone, I'm Guy Menachem from AWS, and thank you for joining us in this AI SRE Summit 2026. It's fun fact, but before joining for working for AWS, I was in Commodore. I really love people, product, and the company, and I'm really happy and excited to be in here. And today we are going to talk about the future, or even like the existing of observability and how it's changed and going to change using Gen AI. So the main question is going to be like, do we still need to observe? Like, is everything we worked on and invested a lot of time in observability is actually going to quite a change? We did this talk 2 years ago, and I think it's quite different. And the observability is actually getting a lot of changes, like everything else on the last 2 years. So let's imagine, for example, a simple scenario like you get some incident in the middle of the night. So you get this page duty where you're waking up, you're going into your laptop, uh, people may be slacking or email you, and everything is just a little bit chaotic. You open your laptop, you go and you're searching through your observability tool, through the dashboard, trying to figure out what happened. It takes you a very long time. uh, After some time, maybe like 30, 40, 45 minutes, you're finding the root cause. It takes you a few minutes just to apply it, deploy everything, and now everything is good. So it took us a very long time. We spend a lot of time, effort doing the investigation. And the main question that we ask yourself is how much out of the 45 minutes we are spent like to understanding the problem and fighting the tools we have. Because like any other dashboard, everything you need to find, you need to know, and maybe you are the experts of the dashboard, but sometimes you are not. But you need to fight the tool or the tool actually helping you. And something that very interesting about the tooling is that we are paying a lot for observability tools. Observability tools are quite expensive. Um, 15% or up to 25% of the observability of the infrastructure bill is going to observability based on honeycomb analysis. Most of the alerts we are getting are pretty noisy, meaning that we are spending time and effort and waking up in the middle of the night or getting interaction like attraction in the middle of the day about 70% of the noisy alerts based on the live action observability report. And what is quite interesting is that most of the teams are getting surprised about how much observability is actually cost them. So what we are going to talk today is the future of observability. How we are able to observe much better, how we are able to be more generally operational focused, and how we are able to be much more efficient with our observability, with our tooling, with AI. So starting from the beginning, let's talk about the AIS DLC. I guess it's something that you're hearing a lot these days about, okay, everyone got some AI that helps them do a lot of things. AI helps us to build. Like, when was the last time you actually printed or worked with a full command? Or when was the last time you actually wrote every code or language that you're working with? Like these days, partially gone. Like we don't need to full code. Some do, but some are not. And AI is actually in every part of the SDLC, from the spec, from the design, from identifying, from analysis of the data, like even before we are started developing it, for reviewing the PR, writing the code, designing the spec, architecting the solution, generating the test, bugs. Everything is using AI. So ASDLC is like a common term by now. I guess you all know it, but it got like a twin, and it's the AI OLC, which is the operation part of the operational lifecycle that we can use AI to do it. I guess that some of you do it already today, but the AI OLC is actually live, and we see that in many aspects of operations. It can be from cost optimization, observability, deploying fixes, getting maintenance. Everything is part of the OLC, and which is like a complementary to the ALS DLC. And today we are going to focus mainly on observability. And we need to ask ourselves, like, does AI helps us to actually operate? Are we more efficient with AI or not really? And what we want to focus on is that can AI help us to collect telemetry, write queries, build dashboard, detect anomalies, and even helps us during the investigation? So for that, we want to take a look on the observability stack. And the observability stack is what you got in place to able from collecting the data of the observability and telemetry that your system makes. It can be from the infrastructure, from the middleware, from the software, from the application, from everything you got, all the way through maybe something can help us to remediate. Some of it is manual and some of it is automatic. So if we break it down, there are like three main parts to the observability stack. And the parts are, first of all, collection. Collection and storage are how do we collect the information? How do we ship it through our infrastructure? And how do we store it? And we call this the data layer. The data layer is very crucial because without the data layer, we are not able to collect and actually store the metrics and telemetry our system makes. The other aspect is data, or the data that we collect. The other aspect is more on the insights part. What we are able to do with the data we collect and store. Are we able to query it? How do we do that? Do we have like a query engine? Is it something common? Um, do we have any specialized language for doing the queries? What the query engine that we are using? This is the query part. Usually different from vendor to vendor, but there is some query language that you're using to query and fetch the data from the storage. The visualization part, usually it's tied together with the query part because we need to query and then we visualize and show it in dashboard. This is the more, I would say, the reactive approach and semi-proactive approach about how do we able to see and visualize what we have. And the last aspect of it is the alerting. Anytime we identify an anomaly or something that is different, we want to get alerted. So this is the insight part. What do we do and how do we collect information from the data? And the last part is actions. What do we do when something goes wrong? Do we investigate, like we mentioned on the previous example before, and are we able to remediate? And if we got all of that building blocks, we actually got like the full observability stack, from the collection to the storage to how do we get insights from it, what are we able to build with it, and the last part, are we able to investigate and remediate as fast as possible to get into the root cause and actually fix things. And all of this stack need to be our partner, our helper, and our engineer that will help us to get through the remediation investigation as quick and as possible. And everything needs to be aligned together to make it as much as efficient and as much as easy for us. And and now what I want us to do is to deep dive to any one of the aspects in here, like to go and talk about how the collection looks like, how the insights layer looks like, and more of that, how the action layer is going to look like. So by now, we just talk about what is it, but let's go one step deeper. Intelligent data collection is actually how do we are able to collect better data and to help us drive better decisions using the data we are collecting. And it starts with how do we sample and how do we collect this information? And there are like, I want to take two examples in here. One is the infrastructure and the other one is the application. For the infrastructure, collectors of metrics are able to collect a lot of data. You can let them scrape a lot of metrics and telemetry from the infrastructure. For example, question that some people collect and some companies collect and some companies not is, for example, network metrics. And how many of them are you collecting? Um, and we need to take a lot of decisions about what we are collecting, because from one side it can create some stress on the system and make the collectors to work very hard and utilize CPU, memory, and network traffic for that. But on the other side, we do store them somewhere and there is a cost for that. We mentioned observability cost, and we need to be smart with the sample and the collection. On the application side, we need to write, in most of the cases, some code that will help us to do that. And what really interesting is that AI can help us to drive decisions and help us to modify that. We want a model that will be able to help us and drive us forward. So from now on, we don't want you to take decision. We want to help AI to help us take decision and always monitor and reduce some of the sample and expand some of the samples and help us drive toward more data-driven decisions when it comes to observability. But on the other side, helps us to take the right samples and the right approaches and help us to manage that uh, quite quickly and efficiently. The other part is contextual enrichment. We do want to do auto tag for the service teams and topologies. This is really important because if you're working for a very large company and you don't have tagging and you don't have everything set up in place, it just goes through a lake of data, which is very hard to query and get insights from. Usually, when we had to tag this data, and it can be tagged for observability and other tags for cost, it usually takes a lot of effort in order to get it in a very efficient way. And we do want to use AI in here to help us to do contextual enrichment and help us to build the right context and the right tags so we will be able to query efficiently. Dynamic routing is something that we call odd path and cold path on the way of where do we want the data to reside and where do we want this data to be queried. Maybe some of the data is not very important in most of the cases, but we do want to have it. So maybe odd path will be the things and the alert that we have on a day-to-day, and the cold path will be cold storage that we do collect and send telemetry, but we send it on to some cold storage that we will be able to query it, but not necessarily on a daily or real-time need. So we will need that data in the future. We do want to optimize cost in here, and we will store it, for example, on Glacier or some cold storage to help us do that. And maybe AI can help us decide what should go to the old cold and hot path based on what we are using. And the last part is auto instrumentation. It's part of the sampling. Like sampling can help us to reduce the number of samples and what should we drop. And instrumentation can help us to instrument much better and get much more insights from our code. And when we are talking about data collection in general, we have to talk, especially around Kubernetes, we have to talk about OpenTelemetry. OpenTelemetry, for those who don't know, helps us to instrument and actually becoming the de facto standard for how do we collect data and telemetry from our services and infrastructure, and how do we ship them into stores of observability. And based on the CNCF annual review 2025, 78% of the organization actually using OpenTelemetry in production, meaning it's getting widely adopted. And the thing is that GenAI already know OpenTelemetry, and we are able to use that in order to do everything we talked before using OpenTelemetry and our LLM models to make everything much better with the standard for how do we collect and ship telemetry and observability in our system. So OpenTelemetry and GenAI really give these things a boost up, because if previously we had to adapt ourselves and to know our system and our shipment and our collectors, now everything is becoming a standard. And the good thing about standard and LLM models is that the LLM models knows the standards. And now, after we get all of the data, we ship it to the right place and we are thinking to ourselves, okay, can we get insights from it? So, if you work in the past 5 years or even more than that in the industry, you better know the query language of your observability tool. And you had to know the tool that queries the data that we got. It, it can be for observability, for databases, basically for everything that we are working with. And each observability system and engine had their own query language. So if you're working with Prometheus, you need to know PromQL. If you're working with New Relic, Datadog, CloudWatch, whatever, everything had their own observability and query language that you needed to know. The interesting part was anytime I had to do a query in a system that I don't know or I need to learn the syntax, it was like cumbersome. Like, how do we do that? Going to search, going to read documentation. Sometimes even the query language you're using, we need a different operator that we don't know. So now, query becoming much, much, much easier. We have this agentic layer, this agent or whatever that will help us to query whatever language we got. We really don't care what is the query language anymore. It needs to be optimized and can search in a very optimized way. It needs to be lean. It needs to be efficient, but we really don't care about the syntax anymore. Only what the language and more important, the engine is capable to do. So now when we got this agentic layer, it doesn't have to be only agentic layer. It does not transform, I know, SQL or PromQL to whatever language we got. The interesting part is that it's able to translate natural language into any query language that we have. So it's not, as I said, PromQL to whatever QL. It's show me whatever things I'm looking for, and based on that, pick actually the PromQL. So 2 years ago, when we did that, we had to go through, I know, whatever LLM that we are using to the web application, writing, we got a query, we pasted on that, and now we see that agentic capabilities and AI agents actually working inside our console, inside our machine, and everything becoming natural language, which is a boost up not only for the users, but the way we get at. But now when our agent knows not what we are looking for, but how to do observability better, because it's not learning and adopting only for ourselves. It got like all the industry best practices of, okay, we have a new service. What do we need to do in order to make it run? More than that, it knows how to configure everything we need, how to get monitoring and observability to the next level and the best practices of the industry anytime we need. And we need to put zero effort to make that work. So in the old way, we had to like design something, maybe a copy a dashboard or copy some query from other services. But now, and it's more than that, right? Because we need to add the panels, we need to decide what we want to do, maybe to clone and match to ourselves. We need to match the query for the services we are working in. If it was another backend API service, it was easy. But if it's something different from the other things we can copy, it was completely different. And then we had to create the alerts and maybe runbooks and wikis so people can understand what to do and what to look for when something goes broken. And now it's natural language not for querying. It's natural language for setting up best practices industry. Set up monitoring for the payment service. Okay, now the agent is going to actually do everything we need in order to put it in place. Discover the endpoints, generating the dashboard, creating the alerts. And to be honest, it's interesting to see if we are going to use the dashboards or actually some agentic will actually query the dashboards. Um, so this is like the next way and how we are going to work on it. But when we are working with that, we can also connect our capability and our metric system to an agent that is not deployed by query language. It can be, first of all, based on human interactions, but more than that, it can live for itself and always monitor ourselves. So here is like a reference design. It's AWS based, but you can take it to whatever architecture that you like, with an agent that is a SRE support agent and helps you to do that. So on the left side, basically, it gets requests from the customer, from the user. There is the agent running on the middle, and it connects to a lot of tooling that helps you to actually query and get this information. You got this authentication of the user, so you can do actions and do things on behalf of the user. It knows the user, but saving and retrieve information through the memory. And obviously, it's connected to the top models that help us to connect and be powerful with what we are using. And the agent itself, it's not like living in isolated zone. We also need observability for the agent on what he does. And we can connect our agent to our observability and get observability about the agent itself, and then obviously run an agent that will observe the agent. So this is a very imperative way and a conversation way to work with the SRE support agent. But we can make the agent to live on their own and fire up when an alert is firing, and once every while check the metrics and see that everything is fine. And the agent can be a very powerful tool to help us do that. This is just a reference implementation, an example of how we can connect everything and making sure everything is working together. If you're looking to deploy that exactly example, it's available through the AWS samples GitHub. So you can find this example, and by a few simple commands, you can deploy this example. And you can even copy it and match it to your own system to get the value out of it. And the next question we are going to talk about, like, is observability portable? What I mean by portable, like previously, when we collect the information using a specific collector that work in the same way, and we deploy the collector configuration through all of our nodes and instrument through our code, it was very vendor specific. And then we use the storage or the system to store those metrics in a very specific way. And then we had a query language that will help us to do that. Everything is quite changing, right? Collection is kind of portable. We are using open telemetry. We don't care where we store the information. We are maybe looking for the best like engine in terms of cost and optimization and performance. And the query is a non-issue because I don't care what is the query language anymore. Agent will write all the queries for me. And now everything is portable. Like, that's it. I can port, I can switch, I can move from one or the other. It is true that if I have historic data, it will be hard to port that and move it to a different system. But it's actually portable. Like, I can decide that next month we are moving from one vendor to the other, and we can democratize a bit observability. But I don't think it stops with query. Actually, visualization and alerting becoming portable too, right? Previously, if we had 300 or 500 dashboards within the company, it was very hard to move them from one observability dashboard system to the other. But now we can give it to an agent and it will generate the exact same dashboard on the target system and also the alerting. And while we have that, investigation and remediation becoming much more portable, because if we are using the same query language, agnostic query language, and we don't care where it's stored, and the alerting is agnostic, Obviously, an agent is agnostic to the query, and the remediation is agnostic to everything. So, to the infrastructure we are working with. And now, what we see is that the observability stack fully is portable. We can move from one to the other very, very easily. So, the thing is, we are moving from write once to run anywhere future. So we can write our telemetry, we can run whatever you use, we can ship it from one, and the Gen AI will be our translation layer from natural language and from engines to how do we use it. So we will query in English, AI will translate everything, and we are able to switch and move from one vendor to the other. And the observability stack will be something that you care less about, but the top layer of how do we remediate and can we get the insight and the actions as fast as we can, this is the things we are going to care about. Is anything on the underlying aspects and the underlying layer is able to provide us with this quality. So going back to the first question, do we need to observe? So in the future, when alert fires, the AI agent will be triggered. It will find the root cause in an autopilot mode or self-pilot AI agent. A rollback PR is drafted. Another agent maybe would approve it, depends on how fast we are going. And you can approve it, do it from bed, maybe hopefully from the phone, not even need to go to the computer, and everything will be resolved much, much faster. So the data will be much collected in a much smarter way with different processes and the way we get it. The query will be in plain English and even by agent, we know automatically. The investigation will be automatic and the portability will be better than ever. So I think we are facing a really change in how AISRE is and the future of observability, and how we are going to do that in the future. Um, that's it for me. Thank you for having me. Thank you for joining me during this color session. If you have any questions, comments, something that you would like to mention, feel free to write it here on the chat or ping me on LinkedIn or Slack. So thank you all for joining. I hope you are enjoying your day and I hope you are enjoying the future session.